Let's look at a definition now, and we want to consider what exactly is a function. So, what is a function? Well, I'm going to tell you, well, a function is practically a relation, right? It is like a relation. Each of the maps that you saw from one set over here to another set is considered a relation. But what exactly is a function? Well, the first thing I'm going to tell you about it is it's a well-behaved relation, right? So in other words, it maps from one set to another, but it follows certain rules. And there's really only one rule for it. So it is a well-behaved relation. It is what? A well-behaved relation. Okay, so you already know what's a relation. Relation's a map from one set to another. Okay, so how would a function behave? How would it be? How would a relation behave in order to be considered a function? Well, I'm going to tell you that. Okay, so I'm going to give an actual definition here. A function, firstly, is a well-behaved relation. So is a map that assigns to each element in the source, which means the set from which you map from, right? Exactly, or at most one element in the target. So every element in the source goes to at most one element in the target. And I want you to think very, very carefully about this. The definition is there must be a map, and that particular map must map from one thing to exactly one thing in the target, right? And let's check that condition. Let's go back. Well, let's check this very first one. If we look at each of the elements here, do they map to exactly or at most one element in the target? And just to satisfy that definition, I'm going to remove this quickly, and then I'm going to also map 8 to that over there. Does it satisfy it? So you ask yourself, let's check 2. Does 2 only have one friend in B? And the answer is yes. Does 4 only have one friend in B? Yes. 9? Yes. 7? Yes. 8? Yes. Every element in the source over here is mapped to exactly one element in the target, right? So we can consider this thing over here to be a function. So I'm just going to write it big over there. This is a function. Yes. Okay. Then if we look at this one over here, everything over here maps to exactly one element in the target. What about this one over here? Now, do these things over here go to exactly one element in the target? 1 goes to one thing. What about 9? Yes, goes to one element. What about 13? It also maps to one element. But what about 4? Let's look at this carefully. 4 maps to both dot and it maps to heart. So your question you need to ask is, when I look at the source, when I look at set A, does every element there go to at most one element in B? And the answer is no, because 4, if I look at 4 over here maps to both dot, and 4 over here, the same 4 maps to heart. So I can consider this thing over here to be not a function. Right, let's just get a thick pen because I'm writing in green, so I'm just going to put there not a function. Right, it certainly is a relation because it's a map from one set to another, but it is not a function because a function would only take things here and map to exactly one thing there. So whenever we see something that's a one-to-many map, it's not a function, right? And then finally in this case over here, if we look at the elements, does 4 go to exactly one element? Yes. Does 27 go to exactly one element? Yes. Does 13 go to exactly one element? Yes. What about 7? Yes, it also only goes to a single element, right? And what about 2? 2 goes to one element. So what I need to do is I need to ask myself over here, am I taking all of these and do they map to at most one element in the target? It doesn't matter if they go to the same element. So for example, 27 runs to cylinder, while 13 also runs to cylinder, and 7 also runs to cylinder. Each of them run to the same thing, but each of them only approaches one thing. Okay, so this here is a function, yes. Right. Every element in the source is mapped to exactly one element in the target. That's a function. This here, not a function. This, the other one we've seen. Okay. Yeah, so simply put, a function is just a well-behaved relation, and it is a map that assigns to each element in the source exactly one element in the target. Like we've seen over here, this here goes to two different things, while this over here goes to multiple things, go to the same thing. And so one thing I'm just going to add to that is, when you see 1, if the relation is described as 1 on the end, right? If it is described as 1, in the target. They only go to one thing in the target. For example, 1 to 1, thin pen, that's a bit thick. One to one, this is a function, right? Many to one, like I've got multiple things in the source, but they go only to one thing in the target, then I know many to one is also a function. Right, but if I've got the reverse, for example, 1 to 1, that's still a function. But if I take many to 1 and I turn things around, like we've got one thing in the source, like you've seen over here, one thing in the source going to multiple things in the target. This one over here, one thing in the source, the 4, is going to both dot and it's also going to heart. That is certainly not a function. So I'm going to put that on this side. When I have 1, too many, like one element going to different elements in the target, that is not a function. Okay. Sometimes teachers in high schools, they use the word relation to describe a non-function. The reality is a function is still a relation, but it also obeys certain rules and conditions. Okay, so one to many, not a function. But if you see a description that shows you 1 in the target, just 1 on that side and 1 on this side, right? This is certainly a function, and so is this over here. Okay.